Okay, prove that root 3 is irrational. So just like the previous one, we'll do the opposite. And we'll assume that root 3 is actually rational. Okay, we'll just assume this. It's rational. So if it's rational, what we can do is we can write root 3 can be written as a fraction, yeah? Because every rational number can be written as a fraction. If it's irrational, you can't do this. So we can say root 3 is equal to a and b, but we're going to put a sort of condition to this, and we're going to say where a and b have no common factors, okay? Except one, of course, yeah, because every number's got a common factor of 1, but it's got no other common factors. And we should be able to do this, yeah? If we can write it as a rational number, a and b should satisfy this, because if it didn't, you could simplify it down, yeah? But I'm saying now that my a and b have no common factors, okay? So, except for 1. So we've got that situation there, yeah, where I'm writing root 3 as this. What I can do then is I can take that b over to the side, and I can do b root 3 equals to a, and I can square. Okay, now squaring both sides will help because it'll get rid of that root 3. So squaring both sides, well, I'll have b squared. If I square that, if I square the root 3, it just becomes 3. And I get then a squared there. In other words, a squared is equal to 3b squared. Now, what this means is that if a squared is equal to 3b squared, that means a squared is a multiple of 3, yeah? Because it's 3 times something. So a squared has a factor of 3. Now, what's true, if the square number has a factor of 3, then the number itself also has a factor of 3. So we can say that. So if a squared is a factor of 3, then a has got a factor of 3. Now, if a has got a factor of 3, we can then, because we know it's a multiple of 3, we can write a as 3 times, say, k, where k is a constant. Okay? Now what I can do then is sort of bit of a process here to get to this sort of situation where actually it can't work, okay? And we're sort of almost getting there. But what we can do now with this, because a is a multiple of 3, it's got a factor of 3, I can now sub this back into here, okay? So I can put a squared, well that'll be 3k squared. If we put that back in here, equals to 3b squared. So therefore then I've got 9k squared equals to 3b squared. Okay, so just sub that in here. And then actually I can say then b squared, well if I divide by 3, b squared is equal to 3k squared. Okay, so therefore I could say, just like I said before, b squared has a factor of 3. Okay, now if b squared is a factor of 3, that means then b is a factor of 3. There's our contradiction. Notice we've got a as a factor of 3, also b is a factor of 3. That's a contradiction. Because we said in the definition at the start that root 3 can be written as a over b, where a and b have no common factors. What we've established in this situation is that a is a factor of 3 and b is a factor of 3. Well, they've got a common factor other than 1. They've got a common factor of 3. Therefore, this can't actually happen. You can't do this where a and b have no common factors. Okay? But you should be able to, shouldn't you, if it's rational? But it's impossible to do it according to this explanation here, in that we've got, both of them have got factors of 3. So it's a contradiction. Therefore, root 3 cannot be written as a over b. Okay, so therefore root 3 is irrational.